In this video, we'll introduce the concept of human-in-the-loop for AI agents. We'll use that implemented using interrupts in LangGraph to implement CQRS for tool calls. We'll rebuild a blockchain AI agent with these new concepts. To do so, we can no longer use LangGraph's pre-built create React agent and instead use StateGraph to manually construct our AI agent to enable this custom CQRS logic. The tech stack is the same as before: OpenAI, OpenRouter, LangChainJs, LangGrapHJs, and of course Hedera. Previously, we have started from scratch and built agent.js, which is a blockchain AI agent with very minimal functionality. If you have yet to, go watch the video from the beginning of the playlist, and links will be provided in the description. Hi all, I'm Brendan and welcome to Hands-on DevRel. Before we begin, let's talk about CQRS. Martin Fowler has a great article on what Command Query Responsibility Segregation, or CQRS, is. Link will be provided in the description. The basic premise is that instead of having a single system which corresponds to both commands and queries, we have them as separate systems. We aren't going to use this concept in its full extent, but rather simply borrowed a partial idea, which is where queries are where we access state but never modify it, and commands are where we both access and potentially modify state. In the context of the AI agent we will be building, we want the LangChain tools that are queries to be treated differently from the LangChain tools that are commands. Specifically, we want the tools that perform a blockchain transaction, which updates the state of the blockchain in an immutable manner, in fact, to be the commands. So, once we've separated tools into commands and queries, what do we do with them? The idea is that we want to introduce human-in-the-loop for the commands. Think about it this way. When you operate a blockchain wallet, the wallet has access to the cryptographic keys. In theory, the wallet could simply sign whatever transactions it wants. But it doesn't. That wouldn't be a very useful wallet, and it's certainly not one that I would ever use. Instead, it presents the transaction details to you, the human, and asks if you would like to perform the transaction or if you'd like to reject it. So imagine a MetaMask transaction approval screen, right? This means that whatever DApp is requesting the transaction will need to pause while the human makes the decision and then resume once a decision has been made. Well, our AI agent that we're building has the same thing. It also has access to our cryptographic keys. We set them in the .env file. Now, what has happened up until now is that whenever there has been a prompt and the LLM decides to make a tool call, that tool call gets executed automatically. But it is time to introduce a human into the loop. Specifically, what we'll want to do is check if the tool calls are queries, and if so, allow them to proceed automatically. This is the same behavior as before. However, if the tools are commands, they cannot proceed automatically. The human is asked to approve or deny the tool calls, which are essentially proposed blockchain transactions, before proceeding. So the human is introduced into the loop, human in the loop, and the point of it is permissions for blockchain transactions. All right. Let's begin. We'll do so by creating an executable script file, and we'll name it CQRS In it, we'll start with some boilerplate imports, then initialize the tools node as we have done in previous agents. However, we do not use create React agent. Create React agent was actually a pre-built state graph that is great for general chat agents. However, when you want to customize the agent's behavior, you'll need to define your own state graph. We'll use add node and add edge here. And essentially, what we'd like you to visualize is a directed cyclic graph where each of the nodes are the different states within the state graph, and each edge is the way in which you can flow through the different nodes from one node to the next. Right, so essentially that forms a directed graph, and in the case of LangGraph, they can be cyclic in the sense that you can go from one node to another node, and you can come back to the previous node again, and that's allowed. Right, so we're going to compile the workflow and check if the graph is valid. The thread ID defines where the chat history will be persisted, and the same thread ID means that the agent can see prior messages in the chat. The start and end nodes are special nodes for the entry points and the exit points of the graph, the state graph. The other nodes are the states that the graph can transition in between. The edges define which states can transition into which other states. So in this graph, the entry point is the agent node, and from the agent node we can go to either the approved node or exit the graph. From the approved node, we can go to either the tools node or exit the graph. And from the tools node, we can go back to the agent node. Essentially, the agent can invoke tools directly, but that must go through an approved node to determine if it'll be allowed to do so. This approved node is the behavior that we want to customize, and hence no longer can use the pre-built graph from Create React Agent. The tools node has already been defined, so we need to define the agent node and the approved node. We also need to define the agent router, which is what is used to determine whether to call the approved node or to exit the graph. In agent router, the logic is simple, which is to check if the most recent message contains some tool calls. In agent node, the logic is also straightforward, to call the LLM and add its response. Same as before. Note that the LLM instance has the tools bound to it. Create React Agent did this automatically for us, but now we need to do that manually. The approved node is where we will put our custom logic for our agent. This is going to be the bulk of our implementation complexity. Recall that what we're trying to accomplish here is that we're going to separate the tools into two categories, query tools and command tools. The query tools, they access state but do not modify any state. The command tools, on the other hand, they both access and potentially modify state. So to put it another way, we're segregating the commands from the queries as per CQRS. Now, in our code, we've already named the query tools such that their name is prefixed with QRY underscore, and the command tools similarly have their names prefixed with CMD underscore. So we define a function named toolCalls with commands to identify when this is the case, essentially to separate the command tools from the full set of tools. Once we have that in our agent within the approved node, after the user has prompted the agent, the LLM will determine if tool calls are necessary. So there are three scenarios here, right? The first scenario is that if there are no tool calls, great, the LLM responds directly and we're done right away. Now the second scenario happens when the LLM needs to perform some tool calls, and all of the tool calls are query tools. Then the LLM can perform tool calls, which is exactly what would happen by default in Create React Agent. The third scenario, this is when the LLM needs to perform some tool calls, and some of the tools that are called are command tools. So this is where we'll need to invoke our custom human-in-the-loop logic. So let's take a moment to visualize this, right? This is where we would pause the execution of the state graph of the AI agent. To pause execution in LangGraph, we'll use something called an interrupt. This is where we display a message to the user, the human, to show what all the tool calls are and whether they approve of them. Think back to the example of the wallet, right? You display the transaction and say, would you like to proceed, right? Yes or no. So we're doing the same thing. If the human approves, then the tool calls can proceed as usual. If the human rejects, then the tool calls are cancelled. By inspecting the tool calls, we know whether we have any command tool calls. And if there are none, we go straight to the tools node because the AI agent does not need permission from the human for that. To do this, we use command and specify a goto that redirects to the tools node. However, If we have at least one command tool that is being called, then it gets more complex. This is when the AI agent needs to ask permission from the human to execute the tools. We'll do this using an interrupt, but first we'll need to construct the interrupt message, which is what we'll display to the user when asking for the permission. Then when we're using interrupt, right, it will halt the execution of the agent graph completely, and it'll return control to the human and await for their response. So the function will exit. When the human has responded, the same node, the approve node, will be called again. This time, the function doesn't exit, and the response from the human to the interrupt message is available. In this case, we're simply detecting if it was a yes or no answer. If the human has approved by responding with a yes, then the agent workflow can proceed to the tools node. If the human has disapproved or denied by responding with a no, then the agent workflow cannot proceed to the tools node, and instead it exits the graph completely. In this case, we'll want to display the reason when this happens. All right. Let's implement a simple utility function that can take in a list of tool calls and return a readable summary of them. This will be used to prompt the user whether they wish to proceed, and it expects a yes or no reply. So, if the human has responded yes, we can use command as before with a goto pointing to the tools node. That's pretty straightforward. However, if they responded no, then it isn't as simple as doing another command with a goto pointing to the end node. It's a bit more complex than that, because this would leave the agent workflow graph in an indeterminate state, and then upon the next prompt, there will be an error that causes the AI agent to crash. In fact, this is where I got stuck for quite a while, working out exactly how not to get the workflow graph into an indeterminate state. First, I started off by creating a Stack Overflow question, and link to that will be provided in the description. And I received an answer with 3 different methods to try. Very promising. Unfortunately, none of them worked. At this point, I thought that there was a bug in LangGraph.js, so I created a GitHub issue, and the link to that too will be provided in the description. Fortunately, one of their core contributors, Ben Burns, was indeed able to figure out what I was doing incorrectly and provide the solution. So here's a shout out to you, Ben. Turns out what needed to be done was to create a new tool message for each rejected tool call. Those tool messages needed to have a status of error and a tool call ID set. He's also copied his response to my Stack Overflow question, which I had bountied, so I'm going to award him that bounty right now. Looks like my bounty has expired, so I'll create a new one and then award the new one. Let's get back to the code. Here we'll need to construct a list of tool messages, one for each of the tool calls. Then we use a command with a goto pointing to the end node, which exits the graph execution. The same command, crucially, needs to add the list of tool messages to the graph in order not to flake out and create an indeterminate state in the agent workflow graph. However, tool messages aren't very useful for the human prompting the AI agent, so we'll include an extra message which is intended to be displayed to the human. This basically confirms that they rejected the tool calls and therefore will not be executed. This chat interface, which we've been using in the previous AI agents, works when there are no interrupts. However, if there are interrupts, as we do now, we need to handle them. Therefore, inside of this loop, we need to inspect the state of the agent workflow graph and detect if there have been any interrupts. Right. Fixing up an oversight here, which is that when an edge has a router to determine which node should be the next node for execution, instead of add edge, it should be add conditional edges. Right. Back to the chat loop. So within the chat loop, if there are any interrupts, we want to display them to the user. And then get the user to type something and send that back into the interrupted node, send that reply back to the interrupted node. We'll copy the existing functions from the prompts and modify them for use in interrupts. The read user interrupt response function simply reads a single line rather than multi-line input. Recall that we're only after a simple yes or no response. The obtain agent interrupt response function, instead of sending the prompt using a human message, this time needs to do something different because the graph execution has been interrupted. Therefore, the agent's workflow graph has been paused and needs to resume. The agent.invoke method needs to send in, instead, a command with resume, and that resume should contain what the human has replied to the interrupt message with. The approve node, which is the one with the interrupts, right? This function gets run the first time and it executes until it hits the interrupt. This exits the function, so the execution will then bounce back to the chat loop, and the chat loop detects that there has been an interrupt, displays the interrupt message to the human, and the human types yes or no. And the chat loop adds a command with a resume, which we've just done, that contains that yes or no reply. The execution will then bounce back into this approve node, and this time it gets past the interrupt, and the interrupt response variable will contain that yes or no reply from the human. This is how the human-in-the-loop gets implemented within LangGraph. Then the rest of the logic implemented will flow. If yes, then go to the tool node. If no, then exit the graph and include a bunch of tool messages on the way out. Since this code is a bit more complex than the one in the previous videos, let's do a quick check to preemptively catch anything that we may have missed. Import the command properly, import the Hedera tools properly, make sure that tools are bound properly, remove this incorrect thread ID import, and correct the thread ID within graph config, which needs to use snake case rather than camel case. This one would have been tricky to catch if not for the fact that I just looked at the GitHub issue. The tool message needs to specify the tool call ID for each tool that was rejected. Otherwise, we still get into an indeterminate state in the graph execution. Then we'll end up with the same error as before, which is not what we want. In construct readable summary of tool calls, fix up the indices such that they're 1 indexed rather than 0 indexed, since these are for display purposes. Also ensure that start and end are imported correctly. Pass the user's interrupt response back to the agent within the chat loop. Let's run the script for the AI agent. For the first prompt, we'll simply ask it for a joke. This should invoke the QRY_joke tool, which is a query tool, not a command tool. Therefore, there should be no interrupts as human-in-the-loop is not required. Next, we're going to ask the agent to submit that joke as a message to this HCS topic. This should invoke the CMD HCS submit topic message tool, which is a command tool. Therefore, there should be an interrupt as human-in-the-loop is required this time. Now we see the output saying agent and in parentheses permission. This is followed by an instruction to review tool calls with details provided and a yes or no option at the end. Let's respond with no. Now we'll see the output saying agent and followed by a rejection notification including all the details of the tool calls that were rejected. Now, let's repeat the previous prompt asking the AI agent to submit the joke as a message to the HCS topic once again. It does the same thing, asking for permission to execute the tool calls, and this time let's respond with a yes. Now we see the output indicating that the tool call has indeed been invoked. Let's take a look at Hashscan. We see right at the top that the joke has indeed been added to this HCS topic. Notably, the joke appears only once, despite us prompting it to do so twice. The first time, since the tool call was denied, the blockchain transaction was not executed. The second time, since the tool call was allowed, the blockchain transaction was allowed to proceed. This time, we're going to use a prompt that will require the AI agent to do something a bit more complex within its workflow. Instead of start to agent to approve to tools to agent to end, instead of that sequence of nodes, it is going to do this instead. Start to agent to tools to agent to approve to tools to agent to end. Or in other words, the agent needs to work out that it needs to perform tool calls in two separate batches based on the same prompt. To do this, the prompt is going to first generate two jokes and then submit both of them as messages onto the HCS topic, right? In two separate rounds or batches. This is impossible to do in a single invocation of the tools alone, of the tools node, because the output of the joke tool needs to be used as input to the blockchain tool. Therefore, it is going to do one batch with two tool calls. Both of them are queries for the joke tool. Then it'll do a second batch, also with two tool calls as well. And both of them are commands for the blockchain tool. For the first batch, since it's queries only and no commands, there's no interrupt. For the second batch, since it has commands, there will need to be an interrupt and therefore will be prompted to approve or deny. Let's check that those two new jokes have been added to the HCS topic as well. So in a single prompt, the AI agent was able to perform two sets of tool calls. All right, we're done. See you in the next video where we'll continue building AI agents. I'm open to suggestions as to what you would like to see next in this next set of videos, so let me know. Drop your ideas in the comments below or anywhere else you can find me on the internet. Subscribe to get notified when it comes out.